This is Algebra Lesson 3-6, Compound Inequalities. A compound inequality is two distinct inequalities joined by the word and or the word or. And in a lot of times when we're working with compound inequalities, we'll use something called interval notation. Interval notation is notation that is used to describe the interval on the number line. It includes the use of three special symbols: parentheses, brackets, and the infinity symbol. Now, you find the solution of a compound inequality either by identifying where the solution sets of the distinct inequalities overlap, which would be an and, or by combining the solution sets to form a larger solution set, which would be kind of like an or. The graph of a compound inequality with the word and contains the overlap of the graph of two inequalities that form the compound inequality. For example, okay, if I say x is greater than or equal to -5 and x is less than 7, that means that we want these things that happen at both intervals. So if I just said that, let's just do this, I will call this point here 0 on all of my graphs. And let's just count by twos. 2, 4, 6, 8, 10 for all of my graphs. And of course, that means this is -2, -4, -6, -8, and -10. Now that my graphs are labeled, let's take that first graph and let's graph x is greater than or equal to -5. And I'm going to do it in a different color so it doesn't get mixed up with my purple. Well, -5 is going to be between -4 and -6, halfway between, and it includes it, so it's here, which means this is going forever in the right-hand direction, getting bigger. And then if we say and x is less than or equal to +7, well, 7 is here halfway between 6 and 8, and we're talking about less than, which means it's going to the left forever. So the combination of the two of those are where this inequality overlaps with this inequality right here. So it's only between the two pink dashed lines. So the answer, since they're both equal to, the answer to this would be a solid circle at -5, a solid circle at +7, and a line that joins both of those two together like this. Right, and obviously we have to graph above the number lines so they can be seen, and in the textbook they will graph between the numbers because they use different colors. I could do that here, but it's harder for you to do different colors on your homework, so I kind of do the graph above the number line just to make it easier to see. So this would be the solution, and if you look at that solution, we could write this solution. We've graphed the solution. The graph is the green line, and the solution to this would be that x is greater than or equal to -5, but less than or equal to 7. X is literally between -5 and 7. And every time you write an and inequality and you combine it into one inequality, the smaller number goes on the left side, the bigger number goes on the right side, and you are always using a less than symbol, less than or equal to or a less than symbol. This is the exact same thing as saying x is greater than or equal to -5 and x is less than or equal to 7. This is written as one inequality, that is a compound inequality, or you could write it as separate inequalities with the word and between them, but you have to state that there's an and there. Now, to graph a compound inequality with the word or, that contains each group of the two inequalities that form the compound inequality. So again, I'm going to number my number lines. I'm going to let this be 0, 1, 2, 3, etc. -1, -2, -3. I'm not going to label beyond that because I think that is perfectly fine. So if I say x is less than -2, less than means that it's not including -2. So x is less than -2 is an open circle at -2 with a line left here. Or x is greater than or equal to 1. Well, it's greater than or equal to means it's a closed circle, and it's here, going to the right. So if I combine the two of those on the same graph, it would be where the two of those things are on the exact same graph. So I would take the top graph, transfer that to the bottom graph. So we have an open circle at -2 with a line to the left. I'd take the middle graph, transfer that to the bottom graph, and it would be a closed circle with a line to the right. There would be the compound inequality, x is less than -2 or x is greater than or equal to 1. So an or inequality, and remember this was the x is less than -2, and this was the x is greater than or equal to 1. So the compound inequality would look like this. It would say x is less than -2. We put the word or in there. X is greater than or equal to 1. So there's two inequalities that you have to write together. Or inequalities 99% of the time go opposite directions, and inequalities 99% of the time face each other. It's kind of like if you went home and your mom said she was going to make hot dogs or hamburgers, you would expect one or the other when you came down for dinner, not both of them. But if she said she's going to make hot dogs and hamburgers for dinner, you would expect to see both of them on the dinner table when you came downstairs. All right, so what compound inequality represents each given phrase and graph the solution? So let's take a look at a couple of examples here. All real numbers that are greater than 1 and less than 5. So this is an and inequality because it says and right here. And I'm going to use a different color here. So numbers that are greater than 1 and less than 5. So 1, I'm going to write this as a single inequality without the word and because that's the way I like to do it. And it's a little easier for people to graph them once they've seen them. So I'm going to have my 1 here because that's 1 is smaller. It goes on the left-hand side. 5 is bigger. It goes on the right-hand side. We always have the less than symbol or the less than or equal to. It says greater than 1 and less than 5. It doesn't say equal. So less than here, and your variable in the middle. So x, you read from the middle out. X is greater than 1 or, and x is less than 5. So literally x is between 1 and 5. That's what that graph actually says, and that's what that inequality actually says. So here's 0, there's 1, there's 5. Notice how it's kind of drawn to scale. So x is between 1 and 5 means an open circle at 1 and an open circle at 5 with a line that goes between the two. Now, if you look at number 2, all real numbers that are less than 10 or greater than 15. So now we've got the word or, which means we have to write it as two inequalities. So if I let x be my variable, x is less than 10 or x is greater than 15. Literally rewrite it exactly as it's stated, putting the word or in the middle. So to graph this, this is 0, let's go 5, 10, 15, 20. Less than 10 is an open circle at 10 with a line that goes to the left. Greater than 15 is an open circle at 15 with a line that goes to the right. So there we have the inequality of x is less than 10 or x is greater than 15. Okay, now a solution of a compound inequality joined by and is any solution that makes both inequalities true. One way you can solve compound inequalities is by writing two inequalities. Another way is by working on all three parts of the inequality at the same time. Again, just like always, you work to get the variables alone between the inequality symbols or the variables isolated, just like we've been doing for quite a long time now. So if I look at this first inequality, we have this as -6 is less than or equal to 3x, which is less than or equal to 15. I will show you how to solve this two ways, and then I'm going to just solve them the way I normally particularly solve them. We could rewrite this as -6 is less than or equal to 3x, and 3x is less than or equal to 15. All we did was take that compound inequality and write it as two separate inequalities with the word and between it. So you should be able to go from what's in the black to what's in the purple, or from what's in the purple back up to what's in the black. So to solve the -6 is less than or equal to 3x, I need to divide by 3. So that gives me -2 is less than or equal to x. And over here, divide by 3 again. X is less than or equal to 5. Notice we did the exact same thing to both equations because it's simply really one equation that was two equations written as one big compound inequality that we separated back into two inequalities. So if I wanted to rewrite this so that I could graph it pretty easily. I can rewrite it with the and like this, okay? Or I could rewrite the solution, x greater than or equal to -2, less than or equal to 5. Okay? So I would simply, here's 0, say this is -2, this is 5. X is literally between -2 and 5. It's sandwiched right here in the middle between those two numbers. It's equal to 2, -2, equal to 5, and a line that joins them together. Okay. I find that it's much easier to solve these as one inequality rather than trying to write them as separate inequalities, because somehow people lose parts to the separate inequalities, which is never a good thing. So I tend to take them, and if you take a look at equation number 4 here, -3 is less than 2x minus 1, which is less than 7. Basically, we have two lines to our fence, don't we? If I was to, I need this, oops, I need it in, let's go yellow. I have a fence here, and I have a fence here. Okay, so basically what we're doing here is we're trying to get the 2x, we're trying to get the x in the middle all by itself, isolated, and everything else is on one side of the inequality or the other. So to do that, if I was to look at this inequality, I would add 1 to the middle, which means I also have to add 1 to the right-hand side and add 1 to the left-hand side, because that's where my yellow dotted lines are. So if I do that, -3 plus 1 is -2, which is less than 2x, which is less than 7 plus 1, which is 8. Whatever you do to the middle, you do to the right-hand side, and you do to the left-hand side if it's a compound inequality with the and in it. So now I'll divide by 2 to the middle, divide by 2 on the right, divide by 2 on the left. So -2 divided by 2 is -1, is less than x, which is less than 4, which means x is literally between -1 and +4. Oops, -1, not -4. That's why we love erasers. Okay, so x is greater than -1, open circle at -1. X is less than 4, open circle at 4, line between the two. Number 7. Let's take a look at number 7 here. Number 7 says 7 is less than -3n plus 1, which is less than 13. Again, very much like problem number 4, this time I'm not going to draw the vertical lines. So I look at this, I look at my 3n, and what did they do to -3n? Well, they added 1, so I need to subtract 1 from the middle, subtract 1 from the right side, subtract 1 from the left side. 7 minus 1 is 6, which is less than -3n, which is less than 12. Now I got to get n by itself. To do that, I'm going to divide by -3. And remember, when you divide or multiply by a negative number, that inequality symbol still switches. It doesn't matter if it's a compound inequality or not. So we have -2 is greater than n, which is greater than 12 divided by -3 is -4. Now we can't write the inequality that way, because I told you all compound inequalities, the smaller number has to be on the left and the larger number has to be on the right, and we always use the less than symbol. So if we look at just this part of the inequality, it says n is greater than -4. So -4 is less than n. That's where, if you read from the inside out, n is greater than -4, if we read this way. Okay, and then n is less than -2. So there it is. So the smaller numbers on the left, larger numbers on the right, and the inequality symbols are flipped, which this inequality up here is the same as this inequality down here, but it's written properly. You never write an inequality where your larger number is on the left. So now if I go to graph this, well, that was a nice straight line, wasn't it? Let's try that again. I don't like lines that aren't very straight. I will cheat. I will use my lovely smartboard to help me draw a straight line. There we go. Now I have a straight line. And I can simply say over here that if I decide that this is -4, this is -2, and let's go, this is 0. So greater than -4, less than -2, line between the two, because n is literally between -4, excuse me, and -2, and I graphed 0, didn't I? Silly me. I will get rid of that. and fix that right now because silly me, I did not graph what I was supposed to graph. -2, there we go, that's better. And now we have our answer. So this is our solution written as a inequality, and then of course the solution is underneath it. All right, let's take a look at some word problems. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. That means including 84 or 86. In other words, greater than or equal to 84, less than or equal to 86. Suppose you scored 78, 78, and 79 on the first 3 tests. Is it possible for you to earn a B in the course if there is only 1 test left? And assume that 100 is the maximum grade you can earn in the course and on a test. Explain. Well, let's think about this for a minute. We need to prove that we could answer our question. So the first thing I'm going to do is I want to know what my 4th test score is, because I already have 3 tests and it says I only have 1 test left. So I'm going to let x equal my 4th test score. So if x is my 4th test score, I know that an average means I add all the points and divide by the number of tests that I have. So I know my average has to be greater than or equal to 84, less than or equal to 86. Okay. Obviously, if you're greater than 86, you're still going to have an A. I mean, well, you wouldn't have a B, you would have an A. So that's why it's got to be between those 2 points. Okay, we're not talking about a B plus, we're not talking about a B minus, we're talking about a solid B. If you want a solid B, it has to be between 84 and 86 points. So if my average then, an average is you have your scores added together, so we have a 78 plus a 78 plus a 79 plus our missing 4th score. We have to divide that by 4 because that's how you find an average. It's got to be greater than or equal to 84, less than or equal to 86. So there's my equation. Okay, so if I add all those together, 78 plus 79, I get 235. So 235 plus x all over 4 is greater than or equal to 84, but less than or equal to 86. So if I go to solve this now, the first thing I need to do is I need to get rid of that pesky little 4 in my denominator. So just like we did before, I'm going to switch colors for a second here. I'm going to take all of this and multiply this by 4, which means if I multiply the middle by 4, I have to multiply the left side by 4, and I have to multiply the right side by 4. Everything gets multiplied by 4. These 4s cancel out. Everything else, you just multiply. So 84 times 4 is 336, is less than or equal to 235 plus x, which is less than or equal to 86 times 4, is 344. Now to solve this, we need to solve this by isolating x. So to isolate x, I have to subtract 235 from it. So I subtract 235 from the middle. I subtract 235 from the left. And I subtract 235 from the right. When I do that, I'm left with x in the middle, just like I wanted. It's greater than or equal to 336 minus 235 is a 101. That's a funny looking 1, isn't it? It's almost like a backwards 701. There we go, that's better. And then 344 minus 235 is a 109. So the answer to the question, though, said, in order to get a B, you have to score between 84 and 86 points inclusive. The maximum test grade you can get, though, is 100. So is it possible for you to get a B in the course? No, because if the maximum grade on a test is 100 points, there's no possible way. Okay, since you have to score higher than 100 in order to get a B. So since you must score higher than 100 points, (100 points on the last test), it is impossible for you to score a B on here. Okay. Okay. Now, you couldn't have answered that just by thinking logically. Some people are like, I want to think logically on it. No, because they might ask you, what score would you have to have in order to score a B? Okay, so here we answered it. We know we have to be greater than 101 and less than or equal to 109. So we have to score between 101 points and 109 points on a test that's only got a maximum of 100 points. So that's not possible, so you cannot earn a B. Okay. All right. Okay, now when we are solving an inequality that is joined by or, you just solve the two inequalities separately, and then when you list the answer, you must make sure you put the or in the answer. For example, if I have negative 2x plus 7 is greater than 3, or 3x minus 4 is greater than or equal to 5, I simply need to solve both of these inequalities separately. So here, on the very first one, I will subtract 7 from both sides, and I get negative 2x is greater than negative 4, because the 7's cancel out. Divide by negative 2, and x is less than 2, because remember, when you divide by a negative number, the inequality symbol reverses. In the second one, I'd add 4 to both sides of my inequality, and I would have 3x is greater than or equal to 9. Divide by 3, divide by 3, x is greater than or equal to 3. So my solution would be x is less than 2, or x is greater than or equal to 3. And I simply would graph this on a regular number line. Okay, so if I've got 0, 1, 2, 3 there. So x is less than 2 means an open circle, line to the left. Greater than or equal to 3, closed circle, line right. And it has to have that or in the answer. Otherwise, it's not correct. Let's look at number 8 here. Number 8 says 3x plus 2 is less than negative 7, or negative 4x plus 5 is less than 1. So again, solve each one of them separately. So I will subtract the 2 here from the left-hand side, do the same thing from the right-hand side. That will give me 3x is less than negative 9. Divide by 3. Remember, we don't switch the inequality symbol here because we're not dividing by a negative. We're just getting a negative answer, which is okay. So x is less than negative 3. On the right-hand side inequality here, we're going to subtract 5 from the left, subtract 5 from the right. I get negative 4x is less than negative 4. Divide by negative 4. This time we do switch the inequality symbol because we divided by a negative number, so that switches to a greater than 1. So x is less than negative 3, or x is greater than 1. So here we would draw our number line. If I have a negative 3 here, let's say we have a 0 here and a 1 here. X is less than negative 3, open circle at negative 3 with a line that goes to the left. Greater than 1, open circle at 1 with a line that goes to the right. And that's how you do your compound inequalities when they have an or. The last thing we're going to talk about is what's called writing things in interval notation. Okay, you can use an inequality such as x is less than or equal to negative 3 to describe a portion of the number line called an interval. Interval notation can also be used, and the 3 symbols we use are the parentheses. Okay. Use the parenthesis. In other words, it's an or. When a is less than or greater than symbol indicates that intervals endpoints are not included. Use the brackets. When a is less than or equal to or greater than or equal to the symbol indicates that intervals endpoints are included. And obviously, we're going to use the infinity symbol when the interval continues forever in the positive direction, and we'll use the negative infinity symbol when the interval continues forever in the negative direction. And you might go, this is making no sense, Mrs. Sheeline. Well, let's take a look at a couple of examples here. Let's say we have the inequality x is greater than or equal to 2. Okay, that means we're including the 2. 2 is included in the solution. And we're going forever in the right-hand direction or in the positive direction. So the interval notation, you'll notice here that we have the bracket because it includes the 2. and it goes forever in the infinite direction, we end it with a parenthesis because it never ends. Okay? And if it never ends, it's going to infinity. We can't say that it includes infinity because infinity doesn't have an end, so we end it with a bracket, with a parenthesis versus a bracket. If we have x is less than 2, obviously it's an open circle at 2, the line's going to the left. It's going to go to the left forever in the negative infinity direction. So again, because we do not know where infinity ends, we have a parenthesis, negative infinity, comma, to 2. Since we did not include the 2 is not closed circle, it's a parenthesis. Another example, x is between 1 and 5. It does not include 1. It's an open circle at 1, but it's a closed circle at 5, which means we have a parenthesis on the left side and a bracket on the right side, because we don't include 1 in the solution on the left, but we do include it on the right. So if we look at this third inequality again, if we have x is greater than 1 and less than or equal to 5, the 1 is not included. That's why there's a parenthesis here. Whoops, I didn't want to be in still yellow. There we go. But the 5 is included. That's why there's a bracket, because if it's a closed circle, we put a bracket. If it's an open circle, we put a parenthesis. So here in this last one, this was an and inequality. Now we're going to look at an or inequality and write that in interval notation. Obviously, with an or inequality, you're actually going to have to write 2 intervals. So here we can see that it's an open circle. So we would know that we would have a parenthesis at that end. It's going forever in the negative direction, so we also know we have to have another parenthesis in that direction. So that's why we end up with negative infinity on the left to negative 3. So it's literally, we read this as it goes from negative 3 to negative infinity. And then or, since there's a closed circle here, we know there's a bracket on that end of it. And then we put the number 4 there. It's going forever in the right-hand direction, so it's going forever in the infinity direction, which is why we have infinity there. And we end up with a parenthesis. So let's take a look at some examples of could you write these. So what is the graph of parenthesis negative 2, 7 bracket? And how do you write parenthesis negative 2, 7 bracket as an inequality? Well, I'm looking at this going, okay, if it's a parenthesis here at negative 2, I'm going to write my little graph first. So here's negative 2. It's a parenthesis, which means it's an open circle. So let's put 0 here. Let's put 7 here. It's a bracket at 7, so I know that's a closed circle. And I know there has to be a line that goes between the two because there's no or telling me that this is an or inequality. So it has to be an and inequality, which means that's what the graph looks like. It's an open circle at negative 2, a closed circle at 7 with a line between the two. So the inequality itself, let's use x as my variable. I would say that x is greater than negative 2, but less than or equal to positive 7. Okay, so that's how you could transfer that from the inequality to the interval notation, and from interval notation to an inequality. Oh, look at this. I left my little equation out. What is the graph of question mark? Ha ha, that's funny. The graph should say, what is the graph of negative 3 is less than or equal to x, which is less than 5. Okay, so that's what it should say before the question mark there. So what is the graph of negative 3 is less than or equal to x, which is less than 5, and what is the interval notation? Okay, so this again is an and. If we look at this, this is definitely another and inequality. So I have a graph here. This is negative 3. Let's say that this is 0. So this is 5. It's less than or equal to negative 3, which means it's a closed circle at negative 3. Excuse me, greater than or equal to negative 3. Less than 5, which means it's an open circle at 5 and a line that goes between the two, because the x is literally between negative 3 and positive 5. So interval notation, since it's including negative 3, we have a parenthesis there, or the bracket, excuse me, there, comma, and it's going to 5. It does not include 5, so that's the parenthesis. So we go bracket, negative 3, comma, 5, parenthesis. So that is what interval notation would be for that particular graph. It was a lot of material today. Let's take a look at our closure question. Closure question says, explain how you know when to use parentheses or bracket when writing an inequality in interval notation. That's what we just did, so hopefully you'll remember how to do that.